Hello, my beautiful computer science students. Welcome to another lesson in Unit 2 Selection and Iteration. If you're new here, I'm Goldie and I'm here to take you through everything involved in the AP CSA course. We are on Lesson 5 in this unit, and Lesson 5 deals with implementing selection and iteration algorithms. So while we've learned about the if statements, we've learned about the while loop, we're going to see how we can kind of combine them now into helping us code programs that we want, right? So we're going to go through some common algorithms that come up quite often in a program, and we're going to go through and just talk about how we start to develop code for these algorithms. So grab some notes, get settled in, and let's go through these together. So we've learned about the while loop, and we are going to learn about one more loop. Not quite yet, though. First, we're going to learn about algorithms, but the while loop itself, since that's the only loop we know, is what we're going to be using today. Now, the while loop is great because we can use this without knowing how many times we need to loop for, versus the next loop we're going to learn about. It has a set number of times that it's going to be able to loop. So while loops are great when we don't know how many times we might actually have to go through an iteration of some sort. So there's 5 standard algorithms that go along with using while loops. Now these 5 are the ones that are called out in the AP CSA CED. So these are the algorithms that the College Board wants to make sure that you know when using while loops. Now these are all going to be done today without data structures, meaning we're going to go over these standard algorithms without using lists or arrays or anything of those sort. We are just going to use the variables that we know so far. So you have to make sure you know how to use these algorithms to help you code your program just as they are. So these are the 5 we're going to go through today. Now we're going to go through the way we're going to go through this is talking about what the algorithm wants you to do. We're going to go through the steps and then we're going to apply the code to it. So the first algorithm we're going to go through is identifying if an integer is or is not evenly divisible by another integer. And I know what you're going to say. The first thing is always, don't we have an operator for this already? And we do. And we're going to talk about that operator after this algorithm. What I want you to understand with these algorithms is making the steps and putting the code to the steps is the important piece here. That's what we want you to learn. When you can do this with simple steps and learn how to do this technique with simple steps, it's going to make coding those larger steps and those larger algorithms that much easier. So that's why we're starting with something that's a little bit simpler. Sometimes something that's like, oh, well, that was a little too easy, right? That's why we start with these first, so that we can eventually grow this knowledge and apply it to those bigger problems. So let's talk about identifying if an integer is or is not evenly divisible by another integer, pretending we don't already know about the mod operator. Let's pretend we haven't learned about the mod operator yet, right? Let's see how we can use an algorithm to help us determine this. So what we want to do is we have 2 integers, right? The 2 integers we label is a dividend and a divisor. The dividend is the number we want that's going to be divided, right? And the divisor is the number dividing it. So to put an example to that, because, sometimes words are confusing, if I have 20 divided by 3, 20 would be the dividend and 3 would be the divisor here. So if I want to take 20 divided by 3, what I want to do, how can I know if it's evenly divisible? Okay, again, pretend we don't know the mod operator, right? How can I determine that? Well, I set up a loop to repeatedly subtract the divisor from the dividend. Okay, so I would set 20 minus 3 to be 17, and 17 minus 3, 14 minus 3, 11 minus 3. Each time I would take that result and I would want to subtract 3 every time. I would want to keep subtracting that divisor as long as the dividend is greater than or equal to the divisor, right? And then the loop ends, I want to check the value of that last dividend. If it's 0, then the numbers are evenly divisible. Otherwise, if there's a remainder, they're not evenly divisible, right? So notice my pattern here. I kept subtracting 3 all the way until I reached something 2 because it's less than the divisor, the original divisor, I want to stop my algorithm. And since this isn't 0, that means that 20 is not evenly divisible by 3. Okay, so this is a great example of how if we are given an algorithm, if we're given instructions of some kind, like right here, and we have to write code, one of the first steps you can take is coming up with an example like this to help orientate yourself in the problem, right? Like, what am I doing? What are maybe the math steps that I need to do? Here's a great example. Now, with the math steps laid out, we can start to see how the variables are going to be in communication with each other, right? So I see the loop happening. What am I doing each line of code? I'm subtracting 3. So that's what I'm going to have to make sure I'm looping and I'm continuously doing. Then I have to think, okay, when does the loop stop, right? Well, the loop stops when this number becomes less than the divisor. Okay, that's when the loop stops. And then once the loop stops, I have to ask the question with an if statement, right? So this is where the selection comes in. The question, if that number is 0, then we say, yes, they are evenly divisible. If there's a remainder of some kind, then they are not evenly divisible. Okay. So start by, with these instructions, start by sometimes coming up with an example. Okay. Now, the code we want to write is always code that can apply to any situation. So we want to use variables so that no matter what number is stored in those variables, our algorithm works on it successfully. But starting with numbers like 20 divided by 3 can help us visually see what steps we're going to take. Now, I wrote out some very detailed sample steps here. Another way we can write out pseudocode is just with littler steps, okay, and some pseudocode with, okay, what lines of code do I need? Before I make those lines of code, let me come up with some English to put on those lines. So for example, here's the instructions. Identify if a dividend is divisible by a divisor. Okay, so the divisor is not shown and the dividend is not shown, but I want to use those two variable names in my code so that no matter what integer is stored in each of those, I'm going to be able to successfully code it. So what you can do is off to the side, write out the English to it. So I start with 2 ints. That's step 1. I have 2 ints. Next, I want to loop. I wanted to loop on each of those steps the dividend minus the divisor. Now, the divisor stayed the same each time, right? The divisor was always 3 in our example. The dividend changed each time. And the dividend changed, it became the result of the dividend the dividend minus the divisor, okay? So the header of the loop is while that dividend was always greater than the divisor. Now the dividend is going to change each loop, right? It was 20, then it was 17, then it was 14. So the dividend is changing each loop. And I want to keep looping until that last dividend was not greater than the divisor, right? As soon as it became 2, as soon as it became less than the divisor, that's when I wanted to stop my loop. So my header, while the dividend is greater than or equal to the divisor, I want to keep going, okay? Your while loop is something you keep doing while it's true. So dividend greater than or equal to divisor. When the loop ends, if the dividend was equal to 0, we said evenly divisible. Otherwise, it's not evenly divisible. Okay, so those are my 4 pseudocode steps. So just kind of quick steps that I can write out to make sense of the code I'm about to write. So my 2 ints were already written for me, and these are the words I want to use in my algorithm. Then I'm going to write my loop. Okay, what was happening? Well, my loop was taking my dividend, subtracting the divisor, and that was becoming the new dividend. Okay, so think of that step. 20 minus 3 equals 17. And then I wanted to take that 17 and do that same thing to 17. So I can use this compound operator to do that. You could have also written it out as dividend equals dividend minus divisor. If that makes more sense to you, write it out that way. You don't have to use a compound operator here necessarily, but that's what I wrote out. But that's what I want to do. I want to keep doing. When do I want to stop? When the dividend was less than the divisor, which means I have to write my while loop while the dividend is greater than or equal to my divisor. I want to keep subtracting that divisor. And then once the dividend became less than the divisor and the while loop was exited, then I had an if statement to ask. If the dividend was equal to 0, then yes, they were evenly divisible. Else, no, they were not evenly divisible. Okay. Now, I wanted to ask that question at the very end. I didn't need to ask that question every time, which is why it's not in my while loop. If there was an algorithm where you had to ask a question each time you looped, that's when you put it in the loop. Okay, so that's something you also have to think about when you're mixing selection and iteration. Selection is asking a question, iteration is repeating. Okay, so when you write out your algorithm, you have to see, okay, where's my questions and what am I repeating? Here, I just had one question at the very end, so it was outside my loop. What I'm repeating, that went inside my loop. Okay, so here's the algorithm for it. Yeah. Now, of course, we can complete this task without a loop because we have the mod operator, right? Dividend, mod divisor, we have it, right? But we want to make sure that we can start applying these algorithm techniques to code that we can understand. And then we can, like I said, kind of upscale it to these larger projects we're going to do. All right, that's algorithm 1. Algorithm 1. And here's the way to do it without a loop with the mod operator. Okay, let's get into stuff that you can't necessarily do without a loop, okay? Like algorithm number 2, identify the individual digits in an integer. Now, there's a few different ways you might need to use this algorithm. You can apply it to different situations, okay, whatever that may be. But just identifying individual digits in an integer. We use a loop to extract each individual digit. And using that mod operator, we can, quote unquote, kind of get the last digit in a number. And this is a technique that we can use to kind of get what that last digit is. And that's by taking mod 10. Okay. So if I have, for example, a number 12,345, if I modded that by 10, the remainder is 5, right? And 5 is that last digit, right, in that one spot. Okay. If I modded by 100, that would give me 45 if I wanted to get the last 2 digits, right? So these number almost tricks, if you want to say, or techniques to kind of extract from an integer is what we use that mod operator for. So we can use the mod to kind of get an integer. Now, the division operator eliminates the last digit if we were dividing by 10. So here, if I divided 12,345 divided by 10, that would drop the number down to 1,234. Okay, so notice how we kind of got rid of that last digit, and then we're left with the remaining numbers. Okay, again, where might you need to use this in a program? It's gonna come up at some point, okay? Something that you might have to use to solve a problem, play a game, whatever you are coding. So you're gonna wanna know the steps to do this, okay? We repeat these steps until all digits are extracted. So let's write out what that means, okay? Here's an example of when you might need to extract digits in a number. If you wanna print the sum of all the digits in a number. Let's say you have some sort of number and you can see there on the code that's set up for you, it's not shown. That number is not shown. But you have some sort of big number stored in there and you have an int sum equals 0. So sum starts off as 0 and at the very end of this, you want to print off what the sum of all the digits were, right? So if you have the 12, just to, kind of set up the example here. If you have the 12,345, right? You want to add up all of these together, right? 1 plus 2 is 3, 6, 10, 15. The sum would be 15. So if this was stored in number, you want the sum of the digits to be 15 when you're done. Okay. So how can we write code to accomplish that? Well, we're going to start off with sum being 0. And while the number is greater than 0, we want to get the last digit, right? So if we have, again, if you need to come up with a number example to help you make sense of this algorithm, we want to get this last digit. We want to add that digit to sum. So 5 gets added to sum, and then we want to divide the number by 10. So basically what we're doing with this algorithm, we want to say, okay, I want to get 5, add it to sum, and then get rid of it. Then I want to get 4, add it to sum, and then get rid of it. get 3, add it to sum, then get rid of it, right? And I want to keep going until that number becomes 0. Okay? Once it becomes 0, once I've used up all of the digits. And once I've used up all the digits, that means I've added all of the individual digits into sum. Okay? So that's what I'm going to keep going. And those are my steps. Okay? Those are my algorithm steps. I wrote them off 1, 2, 3, 4, 5. And now I'm going to put the code to that. So sum starts off as 0 while number greater than 0. So what am I going to do? I'm going to do these 3 steps. All 3 of these are going to happen inside my while loop because I want to repeat them each time. I want to get the digit, and we said we get the digit by using mod. So I'm going to get the digit, number mod 10. Then I'm going to add that digit to sum, and then I'm going to divide that number by 10. Okay, those are the 3 steps I want inside that while loop. Because notice what's happening here. The digit's going to change each time. I don't need to keep track of the digit, which is why I declared it inside here. And it's going to start off as a new value each time. Okay, because I don't need to keep track of it throughout the loops. Sum and number I do, which is why I declared them outside the loop here. Okay, I need to keep track of those between them. Okay, but sum I add the digit to it, and then number I want to just divide it by 10 to kind of quote unquote chop off that last one's digit. Okay, and then at the end I print off the sum. Okay, and that's algorithm number 2. We got 3 more. Algorithm 3, determine the frequency with which a specific criterion is met. Now that's a very general algorithm. We use this a lot in different scenarios you'll find. So here are some sample steps. We want to create a counter variable that keeps track of the number of elements that satisfy a particular condition, whatever that condition might be. We create a condition that checks if the specific criterion is met, and if it is, we increase the counter by 1, and we place that condition in a loop to make sure it is applied to all elements. Okay, now that is quite a mouthful. This is an algorithm that happens quite a lot with data structures. We're going to apply this a lot to lists and arrays as well. But how can we apply this kind of algorithm to what we already know? Let's write a code segment that checks how many numbers between 1 and 100 are divisible by 3. Okay, so this might be something that we use right now, and we can apply to right now. So let's write out some sample steps here. We want to create a counter and our starting number because we want to check how many numbers between 1 and 100 are divisible by 3. So our header, we want to keep going until num is greater than 100, okay? Because I want to stop at 100. I start when num is 1, and I want to go up to and include when num is 100. And inside, I want to check if num is evenly divisible by 3. And if it is, I want to add 1 to the counter. If it's not, then I don't do anything, right? Okay, there's no other thing I have to do. So if it is, I add 1 to the counter. And then at the very end, I also want to increase num by 1 to keep the loop going. Okay, what that looks like. So I create counter and number. So count is 0. Num starts off as 1 because that was in the directions. Okay. Then I have my while loop header. While number is less than or equal to 100. Again, because 100 was my instruction number. Okay, so while num is less than or equal to 100, what am I going to do? I'm going to check if that number is evenly divisible by 3. And I'll use my mod operator to do it. If you wanted to use your while loop that you came up with in algorithm 1, I mean, by all means, you can do that. But I want to check, is number mod 3 equal to 0? Because if it is, that means that num was evenly divisible by 3. And if it is evenly divisible by 3, I want to increase count by 1. Okay, so count plus plus. And then I want to increase num by 1 at the end of my while loop. Okay, so notice how I kept num on the outside of my if statement, okay, because I only wanted count to increase by 1 if it was evenly divisible by 3. Every time the loop runs, I want num to increase by 1, right? I want num to go from 1 to 2 to 3 to 4 to 5 to 6. Each time I loop, I want to increase by 1 so that I can check which numbers are evenly divisible by 3. Okay? And then at the end, I print off their account numbers divisible by 3. Okay? Yeah. All right. The next algorithm, we got 2 more. Algorithm 4, determine a minimum or a maximum value. Again, we use this a lot with data structures, but we're going to apply it. I'm going to give you the steps and we're going to apply it to something we already know here. So we're going to set up a variable for tracking the minimum or a maximum value that stores the smallest or the largest number as we iterate through whatever numbers we have, right? So set up a variable that keeps track of what the largest or the smallest number that you have is. Use a loop to process each number in your series, okay? Whether that's a user entered number like we're going to do, or if that's a number in your array or in your list, whatever data structure you have, okay? You're going to use a loop to process each number that you want to go through. And inside the loop, we use an if statement to compare the current number with the current minimum or maximum value. And if the condition is met, we want to update the min or max. So if we find a larger or smaller value than what we currently have as our min max, we want to update it, right? Because we found something larger. And we keep updating and we keep checking until all of the numbers we have been processed. And then at the end, we have our min or max value. So we're going to apply this to something we already know, which is going to be user entered integers. So we're going to write a code segment that checks the largest number a user enters up until they enter 0 to end the program. Again, we'll apply this algorithm to data structures later, but for right now, let's just work with what we know, okay? So the instructions, enter a number or 0 to quit. The user is going to enter a number that we're going to store in the variable number. And what do we want to do? We want to keep asking them to enter a number, but we want to keep track of the largest number that they enter. So we're going to create a max variable. Here's our steps. Let's write them out first before we start coding. We're going to create a max variable, and while the user doesn't enter that should be a 0. Okay, because we're looking for a 0 to quit. While the user doesn't enter a 0, we're going to check if the number they entered is greater than the max. Because if it is, we want to change the max, right? So if our max is currently 10 and the user enters a 20, well, hey, they entered a number larger than what we currently have. Let's change the max to 20 and keep going, right? And then at the end, we want to ask for another number. We want to keep asking that number as long as they don't enter a 0. So here's what we're going to do. Create the max variable. So I have int max equals, and then I have this integer dot min value. So if you remember, we kind of talked about this a little bit. We'll talk about it even more in later units, but integer dot min value. Integer is a class that is available to us to use. And min value is a static variable that holds the minimum value of an integer number. So the lowest possible value that can be stored in an integer. This is a constant that we can call on. Okay, so you don't remember what it's a negative, right? Like 2 million something, whatever. I don't even, no, it's not 2 million. It's like crazy number, crazy negative number, right? Like negative 2 times 10 to like, I don't know, whatever. Something, right? No one remembers it, but we know we can get that smallest number by calling this constant. Is that beautiful, right? You don't have to remember that specific number, but you can get the smallest number by calling this constant. Now, why do we want to call it? That's going to be what we have first in our max value. We need to give max some sort of number because we're going to use it in a condition. And in order to use it in a condition, max has to have something stored. It can't just be nothing, right? It can't be undeclared. And we don't want to necessarily put like a 0 in there or a negative 10 or even a negative 1,000 because we don't know what the user is going to enter. The user might only enter negative 2,000, negative 3,000. So if you pick negative 1,000, all of a sudden what you coded in there is going to be the maximum number by default, and it's going to print an inaccurate result because the user entered all numbers less than what you thought might be the minimum number. Okay, so logically, when you code this, it makes sense to make that max the smallest number possible so that any number the user enters is automatically larger than what you currently have. Okay, so there you go. Integer.min value. The opposite would be true if you were looking for a min. You want to make the number as large as possible so that any number the user enters is automatically smaller than it. Okay, so vice versa. So we create the max variable. While the number is not equal to 0, okay, because they enter 0 to quit, okay, ignore the pseudocode steps there. But while the number is not equal to 0, we want to check if the number the user has entered is greater than the max, okay? Because if it is, we want our max to be that new number, okay? Because we're looking for the maximum value. So we want to change the max. If it's not, or if it is, whatever the case is, we then want to ask them for another number. Enter a number or 0 to quit, number equals keyboard.nextInt, and then we want to check this again, okay? Because if they enter a 0, all of a sudden number equals 0, then the loop stops, and we have our max value. If they entered anything else, we go through that comparison and ask the user for a number again, okay? Algorithm number 4, done. We have one algorithm left. Algorithm 5, compute a sum, average, or a mode. Now the mode kind of the mode can apply to like a user entered numbers like we just did, or it can apply to the list too. We're going to talk about computing a average or a sum, I forget. I think we are computing an average here. But whatever our instructions say, we want to, again, kind of set up sample steps for our algorithm, okay? Whether we think through these steps or we actually write out these steps, you want to have a method for kind of processing these directions. You don't just want to jump into the code. So let's say I want to set up a variable to store the sum that accumulates the total sum as we move through the loop, okay? Again, if we're looking at user enter values, if the user's entering values, I want to be able to accumulate the sum as we move through those values. Now, if my instructions were just to compute a sum, perfect. I've accumulated all the numbers throughout the loop and I can print the sum. If I'm looking for an average, well, I needed to find the sum anyway in order to find that average. Now, if I'm looking for a mode, I have to do something a little bit different, but we'll get into that with data structures. Now, while we're using a loop to process those numbers, we want to keep going until a condition is met. Again, like if we're looking for a user and the user enters 0, then we quit kind of thing. After each input, we add the number to the sum variable. Okay, so here are the instructions that could use this algorithm. Write a code segment that asks the user to enter in numbers to add together. Once the user enters 0, the code will stop and the sum and the average of the numbers will be printed. Okay, so one thing logically we have to keep track of is obviously the sum. Okay, we want to keep track of the sum. And if we want to print the average, we also need to keep track of how many numbers were entered. But keep track of all the numbers that were entered, but we don't want to include that 0 because 0 is the number that's the code to quit, right? So we ask the user enter a number or 0 to quit. We get that first number, and then you see at the end here, we're going to print off what sum and our average are. So here's, again, the steps to kind of handle this instruction. So I'm going to create a sum and a count variable, sum to keep track of the sum, but I also need to keep track of how many numbers were entered in order to compute my average. While the user doesn't enter a 0, we want to increase count by 1, we want to add number to the sum, and we want to ask for another number. Okay, so these are the 3 things we want to do. And at the end, we want to calculate the average after the loop. We don't calculate the average as it's going on. I mean, I guess we could do that if the instructions asked for it, but the instructions don't ask for it here. They want to compute the sum and the average after the fact. Okay, so we're going to do steps 3 and 4 inside of the loop. And we're going to make sure that our logic works out there. So I create my sum and my count. Then while the number that the user enters is not equal to 0, I want to increase the count, add number to the sum, and I want to ask for another number. Okay, So I don't need an if statement in here. I'm just asking for the user to input numbers. Now again, let's make sure the logic works out. If the user enters a 0 here, we want the loop to stop. Does that happen? We check if number is 0, the loop stops, and we go right here. Well, we'll go to this area right here where we compute the sum and the average, okay? So we don't want 0 to count, okay? Which is why you don't want to put like count after this, because if a user enters 0, count would increase by 1 and it would actually count towards the final count, okay? And you don't want it to when you're finding that average, okay? So make sure logically that when you're making your algorithm steps, you check for situations like that you check for situations where it doesn't work. It works in a syntax way, but it doesn't work logically like you think it should, right? Okay. Now we want to calculate the average and print off the sum. So average is going to be a double. So I'm going to first typecast the sum into a double and then divide by count. Okay. Oops. And that's the end. I didn't realize that was the end. I was having so much fun. I thought there would be more, but that does cover our 5 algorithms that are laid out in the AP CSA CED. Again, we're using these algorithms, we're applying it to things we already know, but these algorithms are going to come up again when we talk about data structures, okay? And they actually come up again fairly often just in programming in general when we need to accomplish a specific task. We will take these algorithms and kind of tweak them to make them work for whatever task we are working on, right? And then the other thing I want to make sure that you really take away from this is when you are presented with a task and you need to write code for it, there are different ways you can kind of problem solve in order to get the code. You don't have to jump straight into the code. And if you can't jump straight into the code, that doesn't make you a bad programmer, okay? Write out the steps, write out an example, right? Like if sum was this, right? Or the number was this, what would happen, right? Go through an example with a number. Then write out the steps like we did, number 1 through 6. Try to write out the steps just in English, right? Step by step, what am I going to do? And then once you have those, then you can start applying the code and testing the code and seeing if that works out, okay? All right. I'm done talking. I appreciate you guys sticking with me. If you have liked this video, please hit the like button and subscribe to my YouTube channel for more CSA content. But until then, I will see you in the next video. Thank you guys so much.